Hello, and welcome to another day of chemistry together online. Before I get started on today's topic, I want to make sure you are aware that we have our Unit 1 quiz on day 6 of this unit, and today is day 5. So the next day you have Zoom class, that is our end of our unit. It's the Unit 1 quiz. So what I want to give you to start off today is, well, first of all, the topic we are learning today is called sig figs, and that will not be on the Unit 1 quiz. That's too fast of a turnaround. Sig figs is just something we'll keep using as chemists all year. It's not specifically on this first quiz. So, what I want to give you before going into the quiz tomorrow is some ideas of how to study for chemistry quizzes, because this is your first official chemistry quiz with me. So, one thing you could do on the back of our unit plan, it has a list of all the objectives for this unit, and there's little check boxes that say I can, I think I can, or I can't. So the idea is you're asking yourself, could I do that? And if the answer is I can't, you know to get help before you take that quiz. Little interview, because one of the options is I think I can. The next best thing to do to prepare for the quiz is to look back at past assignments. Know your mistakes. If you don't know how to look back at your assignments, you go into the assignment, you hit submissions, and then you choose that submission, and it shows you the graded version with comments and things like that on Schoology. Remember, you've got those unit practice problems. They're in the week 1 folder for unit 1. You can check answers. It's a great way to see some different kinds of questions and just practice some more. You could go back and look at all of your COSTA questions. That was the reason we wrote them, was for you to review. There is no benefit of just looking at your notes. That does not count as studying for this quiz. 1, because it's not interactive, and 2, you get to use your notes on the quiz. So there's no reason to just look back at them. You have to do something interactive. Active learning, active review. So looking back at your COSTA questions and answering those questions is active, or doing the same thing with your essential questions. Summarizing those notes. So look back at a topic and just see if you could summarize it out loud. That audio piece, that saying it out loud or to another person, call up a friend and see if you review with them, or call up a relative or someone from that's not anywhere near you or in your family. Like, just call someone that you want to connect with, have some small talk, and then be like, hey, this is random, but can I review my chemistry stuff with you? Why not, right? You could look back at the video notes, but I don't know if that's worth your time. Maybe if there's one part of a video notes, or if there's like one topic that you're just unsure of, maybe that's worth your time, but you have to decide. And then I do have a review in today's Schoology folder. In the December 16th Schoology folder, there's a review with the answers. So kind of like the unit practice problems, seeing new things to answer is a good way to be actively reviewing. So for those of you that asked me in your Google form, like, one thing I could do to help you this trimester was you want study guides, you want reviews. Here are your study guides and what you can do to review for quizzes. And we'll talk more about the structure of the quiz in our next Zoom, but just so you know, it's 20 multiple choice questions. That's what this quiz happens to be. All right. So, with that introduction of just looking ahead, I now want to get back to our plan for today. So, the essential question for today is the thing that's going to guide our learning. How do I accurately report calculated numbers in science? Last time we talked a little bit about reading a scale on a graduated cylinder or a ruler or a thermometer or whatever it is. You also saw that in the lab where I was picky about numbers I wrote down. Those are being picky reporting science numbers in measurements. Well, what about if they're calculated numbers? Off of a calculator, how do we know what we can keep? That's going to be our focus today. There is a handout on Schoology that is called the SigFig handout. If you wanted to, you could just download that sheet and just take notes on there. There's a lot of stuff already written down, so it would save you a lot of note taking. You could just think about practicing. You could also print it off if you've got a printer and then take notes on there. All right, so our topic for today, so whether you're doing this in your notebook, on the printed SigFig handout, or taking that SigFig handout and putting in Notability, still make it look like focus notes. So your topic is something called significant figures, the date that you're taking these notes, and then the essential question is, what is the proper way to report calculated numbers in science? So put that at the top of the handout or the top of your note page, wherever you're taking these notes, so that you remember what's the point of this significant figures thing. It is very technical and very specific to chemistry. So this is one of those topics that's just really nitpicky, but chemistry is about the details, and you have to report numbers accurately in science. You can't just make up whatever you want. So we got to learn the rules for doing that. All right, significant figures. Let's get into it. Rule number 1. If you're looking at a number and trying to decide if it is considered significant or not, significant means is it a number that makes the measurement more specific or more exact? So if it's not a zero, it's making the number more specific. Like 234 milliliters is a very specific measurement. It's got what would be considered 1, 2, 3 sig figs. So that's what I mean by non-zero is significant. So if I counted all the beads in my crafting bin, 11,928, that is very specific. So that is 1, 2, 3, 4, 5 sig figs. So the non-zeros, if I'm trying to decide looking at a measurement and seeing is it significant or not, non-zeros are considered significant. Okay, how about the next one? If you have zeros that are in front of non-zeros in a decimal number, those are not significant. They are considered placeholders, making the number small. Here's what I mean. 0.0094. So zeros in front of non-zeros. So zeros in front of non-zeros in a decimal number are not significant. This is just a placeholder number. Because look, I could write it like this. 9.4 times 10 to the negative third. So I move the decimal 3 spots this way. So that's where the negative 3 comes from. It's a small number to start with. That's why it's negative 3. So now it's even more obvious. Just 1, 2 sig figs. Why is it 2? Because these are not making the measurement more specific. They're just making the measurement small. So 2 sig figs. So the more sig figs you have, the more exact your measurement. So something like this, 0.000521, these are placeholder zeros. It's only this part of the measurement that makes it more specific. So 1, 2, 3 sig figs. That's rule number 2. All right. Well, what if you have zeros that are after non-zeros of a decimal? Because we talked about how like adding, 54.0 makes the measurement more exact. That would be this kind of an answer. These are called exactness zeros. So 0.000250, these are all significant. These 3 are placeholders. This one is showing it's exactly 0.0025, right? So this is 1, 2, 3 sig figs. Without the 0, then the 5 would have been the guess, but the 5 is not a guess. It's exactly 0.00025, so that's why that 0 needs to be there. We know it's 0.00025. The 0 says it's exactly that, so we get more sig figs. This measurement would only be 1, 2 sig figs, and it would have told us that we read to 0.0002, and the 5 was an approximate. That's the difference. So then 0.100, this would also be 1, 2, 3 sig figs, because these zeros are after a non-zero, after a decimal, making the measurement more specific. Exactness zeros. Okay. Rule number 4, what if there are zeros at the end of a measurement after non-zeros, but there's no decimal? These are, again, placeholders. So this is not a specific 0. It's saying it's somewhere between 347 and 352 or something like that. So that 0 is not significant. It's, again, a placeholder. So this only has 1, 2 sig figs. This one, 11,100, I don't know how far away that is. It's way into the outer space. 11,100 miles. Because it's so far away, we can't be super specific. So 1, 2 placeholders. So 1, 2, 3 sig figs. It's not a very specific measurement. If they are significant, but we can't have any more sig figs allowed, sometimes we will use a decimal point. So like, for example, let's say we were doing a dog show, and our capacity was 800 dogs. Well, without the decimal point, if we're thinking science rules here, without the decimal point, it would look like 1, meaning we could have, it's okay if you have like 813 dogs. That's okay because that's still around 800. No, we max out at 800 exactly. So that dot says all 3 of these numbers are significant. These zeros are now with a decimal, so then they are significant. So this would have 1, 2, 3 sig figs, because it doesn't make any sense to say 800.0 dogs because you can't have a 0.0 of an animal. It's still a full animal, even if it's missing a tail or only has 3 legs. It's still a full animal. So there's no sense. Or if you're thinking about animals as a weird example, what if you were talking about a thumbtack or a pencil? There's still a full pencil, even if it has been sharpened. You can't have a part of a thumbtack. So certain objects that you can't have different decimals of, we sometimes use that decimal point for zeros to show we're being exact. All right. Okay, last rule, number 5. Any zero surrounded by significant numbers is also significant. So if you have zeros in the middle of things that are also significant, those zeros stay significant. Like 1,300.00 miles. So this is a very specific measurement. Maybe my GPS was calculating how far it was to some place across the country. Very specific, just happens to be 0.00. Well, this zero is significant because it's at the end of a measurement after a decimal. And then these are significant because they're not zeros. So then all of the zeros in between are also significant. So this would have 1, 2, 3, 4, 5, 6 sig figs. Very specific. If I was counting the number of eggs I needed for a huge brunch fundraiser, and I'm like, oh, about 2007 should work. This is a significant number because it's a non-zero. This is a significant number because it's a non-zero. So the two in the middle have to be significant because they are making this answer more specific because of that 7 at the end. So 1, 2, 3, 4 sig figs. So that is the first side of that sig fig handout. Just practicing looking at a calculated number. Like if this was a number on your calculator, how would you know how many sig figs it has? That would be what we are just learning. So go ahead and do a level 1 question so far. Listing the rule, the 5 sig fig rules would be a great idea, because if you're using this to review later in the trimester, being able to list off the 5 different rules is kind of a good review. Let's keep going though. Let's do a quick review, and then we'll keep going. So determine the number of sig figs in each measurement. Pause the video and just on your output side, or on the side of your handout, if that's what you're using, or in your notebook on a piece of scratch paper, figure out how many sig figs each of these has. Pause the video. All right, so I'm assuming that you've already practiced this. If you still haven't practiced it, pause the video again and then come back when you're ready. Let's go over the answers. These are all non-zeros, so 1, 2, 3 sig figs. Is that what you said? This has a 0 at the end of a measurement after a decimal. So 1, 2, 3, 3 sig figs. Is that what you said? Hope so. These are placeholder zeros. These are non-zeros. So only 1, 2 sig figs. Is that what you said? Hope so. Okay, we got zeros all over the place. These are placeholder zeros. This is an exactness 0. This is a non-zero. These do not count. This one does, just like these did not count. So 1, 2 sig figs again. All right, 400 pencils. So you're counting up the pencils you need for a practice ACT that we're going to give at Roz. And you're just like, I don't know, I have somewhere around 400 pencils. You did not count them out every one. That means this is not a very specific measurement. 1 sig fig, these 2 are placeholders. How'd you do? Do you get it? This is one of those things that just is really nitpicky details that you will get used to. You just have to keep practicing and listening, seeing examples, thinking about it, asking questions as needed. But again, it's important because a scientist has to know what numbers they're reporting. You can't have more or less than you should. That's what we're learning here. It's a skill for science. Here's a little fast fact for you. There was a guy named Sir Edward Henry who was one of the first people to measure Mount Everest, and he measured it to be 29,000. But he didn't want to write that number down because it looks like an estimate. Now, there's obviously other things he could have done. He could have used scientific notation. He could have put a decimal here. But what he did is he reported it as 29,002 because, of course, at this height, that 2 feet different with ice melt and snowfall and things like that, there's some error involved. So that is allowed. Because look, this only has 1, 2 sig figs, and this has 1, 2, 3, 4, 5. So even though this seems like a random fact, there are people that actually care about sig figs. 29,000 is an estimate. It's anywhere from between something that would round to this, 28,900 to 29,400. That's a huge range. It's only 2 sig figs. So instead, he made it 5 sig figs to show that he was very sure of that 29,000 measurement. So a little connection to sig figs and something out in the real world. Okay, as you saw, I gave you a little preview. Okay, there are so many rules about sig figs, especially about zeros. So here's what I want you to do for your summary today. I want you to write a zeros synquane. A synquane is another one of those creative ways to review to get your brain more actively involved in your thinking. It's a 5-line poem that has 2 syllables in the first line, 4 syllables in the second line, 6 syllables in the third line, 8 syllables in the fourth line, back to 2 syllables in the fifth line. So 5 lines, these are the number of syllables in each line. And just to review, a syllable is like the beats of a word, like syllable has 3. Synquane has 2, right? Summary has 3. You're writing the synquane to review those 5 rules we just learned. If you want to focus just on the 4 that involve zeros, that would be fine because zeros are the things that is tricky. Here's an example of a synquane about zeros. My first line is 0. Between is fine. At end with point, good. Right of point, left of numbers, not. Practice. Yeah, Miss K, right? Okay, so anyway, it's just a silly way to review something, but the silly piece of it is what makes your brain more active. Okay, all right. The next quick thing I want to talk about related to measurements is scientific notation. Again, there's a guide on Schoology if you need more review than the one slide I'm going to give you here. Proper format for scientific notation looks like this. And this is not a Killinan rule, this is a science rule. You only put one number in front of the decimal. There's a times 10, and then there's a power of 10, and then, of course, a label. But proper format for scientific notation always looks like this. One number in front of a decimal times 10 to the something, okay? So let's practice putting these measurements into scientific notation, but let's also practice sig figs. Pause the video and see if you can do this, and then come back. All right, let's see if you understood what I was trying to go for. So only 2 sig figs means you start at the beginning of your measurement. I can keep 1, 2. I look at the next number for rounding, which it does. So I know that this is going to be 3.9, but then I have to figure out that power of 10. The decimal was here, and I moved it 1, 2, 3, 4. So 3.9 times 10 to the 4th would be this number. All right, 3.9 times 10 to the 4th. 1, 2 sig figs. There's one number in front of the decimal times 10. It's a big number, so it's a positive power of 10. Okay, let's try this one. I can keep 2 sig figs. These are placeholders, so they're not sig figs. My first sig fig is here, 3, 2. So 1, 2 sig figs, 3.2 to make it scientific notation. But the decimal was here, so I moved it 1, 2, 3, 4, 5. But this is a small number, so it's a negative power of 10. So 3.2 are my 2 sig figs times 10 to the negative 5 to represent where I moved the decimal. This is my power of 10 to show it's a small number. Let's do this one. So this looks like it already is in scientific notation, but remember, you can only put one number in front of the decimal. So I have to move the decimal 2 more spots, so that's going to become 10 to the 5th. But I'm only allowed 2 sig figs because of the measurements I was doing, so I can keep 1, 2. I look at this for rounding, which it does, and then remember, I put the decimal here. So 4.6 times 10 to the 5th, because this is a big number that I moved the decimal 2 more spots, and so then it's a positive power of 10. Okay. You also have a button on your calculator that does scientific notation. It's the EE button. If you're using like a graphing calculator, Texas Instruments, it's above the 7 and then there's like a comma. It's the second button. We'll talk more about that later. But that EE button puts it into scientific notation for you without having to use time and 10 and the caret key. So like if you would type in this number into your calculator, you would type in 6.02, that EE button, and then the 23. You don't need a times, you don't need a 10, you don't need a power, anything. So then it shows on your calculator 6.02 E23, which means 6.02 times 10 to the 23rd. We will talk more about that when we start doing calculations. Yes, you could still use parentheses and 6.02 times 10 caret 23 parenthesis. Yeah, you can still do that, but eventually it's going to be annoying to keep typing all that stuff in. So get used to using that fancy calculator that you have and use that EE button. It is your scientific notation button. Okay, go ahead and do a level 2 question so far about scientific notation. Make up a number, any number, and maybe do this thing. Put this number in correct scientific notation with blank sig figs. Make up a number, anything, and then just ask for correct scientific notation. Ask for a certain number of sig figs. That would be a great level 2 kind of question. All right. We have one more section of notes we have to talk about, and that deals with we've done the measurements, we've done the calculations, we got a number on our calculator like this. 98.3 divided by 65.2. Go ahead and do this. What do you get? You get this. Well, based on what we just talked about, this has 1, 2, 3 sig figs. This has 1, 2, 3 sig figs. And this suddenly has 1, 2, 3, 4, 5, 6. It has so many. Where did all those extra numbers or sig figs come from? Well, they came from math. And remember, math is not as picky about how many numbers it writes down. In science, every number is earned. We did not earn 9 sig figs if our 2 measurements each had 3. So the next section of our notes is how do we take a calculated answer and give it the number of sig figs that are actually allowed in science. So here's the idea. How do we know how many sig figs we can report in a math problem? It's like a chain. Think about that thing they say about the strength of a chain. It's only as, do you got it? Yeah, only as strong as its weakest link. That means an answer in a calculation can only be as exact as its least exact value in the equation. Another way, the number of sig figs in your answer can only be as many as the least number of sig figs in the math problem that you did. So nothing changes about how we do the math. What we're talking about is get a math answer and now turn it into the science answer because we have to be picky about what we write down. This is the big rule. An answer in a calculation can only be as exact as its least exact value. You can't suddenly have more sig figs in your answer than the least sig figs you started with. Let's talk about multiplication and division. So if you're using that sig fig handout, we're on the other side. We'll do the math like normal, and then start by counting the total number of sig figs for each value of the calculation. So let's say I was trying to find the area of something, meters times meters. 45.20 meters times 1.91 meters. That would give me meters squared. That would be the area of something. Maybe it was a big, like a big rectangle field or something. Okay. Well, this, based on the rules we just learned, has 1, 2, 3, 4, because this 0 is exact at the end after a decimal. And this has 1, 2, 3, because they're all non-zeros. So the rule says when you get this answer on your calculator, do the math like normal, 45.20 times 1.91, you get this. This has 5 sig figs. We're not allowed that. So the rule says your answer can only have as many sig figs as the least number of sig figs in your calculation, which is 3. So that means that this math answer becomes the science answer of 1, 2, 3 sig figs. Here's where you got to let go, a little bit of discomfort. These numbers never existed in science. This is the answer. 1, 2, 3 sig figs. Look at this number for rounding, which it does not. So these numbers drop away. They were math numbers. They were never science answers. So again, this is that part you just have to kind of let go and just learn something new, right? You can't say, oh, it's not the same number anymore. These numbers were never really there in science. They were pretend numbers in math, which is fine, but we're not doing just math here. We're doing science. And your final answer can't have more sig figs if the measurements you used in the calculation are not as specific. That's the idea. Let's try a couple. Go ahead and do these 2 math problems. They're normal division problems. Nothing changes about the math. Get your answers, pause the video, get your answers, and then let's look at them together. All right, ready? So you do 32 divided by 430 just like you always would. You get this number on your calculator. Okay, great. But our least number of sig figs, take a look. 1, 2, 3, 4 sig figs because these are exactness zeros, but this is a placeholder, so only 1, 2 sig figs. So 2 is the least number of sig figs in your measurements. These are science numbers. So your math answer turning into a science answer can only have 2 sig figs. So the answer is, here is my first sig fig. You get this placeholder 0 for free. So 1, 2, look at this number for rounding, which it does not. So this number all gets chopped off. These numbers never existed in science. So the answer is 0.074 feet divided by second, feet per second. So I'm figuring out some type of speed, okay? Same thing, normal division, 0.0091 divided by 0.000521. You get a math answer. It says this, okay? What's our least number of sig figs? These are placeholders. This is exact. So 1, 2, 3. These are placeholders. These are non-zeros. So 1, 2, 3. So they both have 3 sig figs. Okay, but this answer has way too many. This math answer doesn't match our science rules. So the answer, I get 3 sig figs. Start at the beginning. 1, 2, 3. I look at this number for rounding, which it does. So then my answer is 17.5. 3 sig figs rounded to be as close to those 3 sig figs math answers as I can, grams per milliliter. So this is a density type of calculation. All right. Those are the rules for multiplying and dividing, which is mostly what we do in here. However, every once in a while we do addition and subtraction. Now, here's the thing that's new. I promise you this is the last new thing today. When we're adding and subtracting, the only part that matters are decimal places. You might remember back in elementary school when you first learned how to add and subtract decimal numbers, the first thing you do is line up all the decimals because that's the part that kind of changes your math. So it's only the decimal places that equal sig figs, but the rule is the same. You count the number of sig figs, which in this case is decimal places, and you can't have more decimal places than your least number in the measurement. So this has 1, 2 decimal places, 1, 2, 3, 4 decimal places, 0 decimal places. So again, because we're adding, we are only looking at decimal places. Yes, this is one more sig fig rule you have to be familiar with. Lots of little details today. The more you practice, the more examples you see, the more this will make sense. So I'm not looking at the total number of sig figs. I'm looking at just the decimal places because in adding and subtracting, decimal places equal sig figs. So this has no decimal places. So the number that you get on your calculator has to chop off at the whole number because your answer can only have as many decimal places as the least number. So this is the number on your calculator. I have to chop it off at the decimal place. I look at this number for rounding, which it does not. So my answer is just 41 ATM. Because we can't be this specific because not all of our measurements were that specific. So again, letting go of the math answer and getting what the actual science answer is telling us. Try a couple more. So pause the video, do these answers, and then we'll compare. Go ahead. All right. The least number of sig figs, you have to notice that we're adding. So since we're adding, sig figs means decimal places. 1 decimal place, 2 decimal places, 2 decimal places, 1 decimal place. I'm allowed 1 decimal place in my final answer. So when you add it all up on your calculator like normal, your answer gives you this, 13.99. But I'm only allowed 1 decimal place. So I look at this number that I can keep. I look at this number for rounding, which it does, but I have to keep 1 decimal place. So 14.0 degrees Celsius would be my answer. And you can see that math and science answers are similar. So if you got something like 25 as your final answer, that doesn't make any sense. You made a mistake somewhere. So just make sure that your math and science answers are similar, but the science answer matches the data that we got or used to get this answer. Here's a subtraction problem. So maybe something was losing weight throughout some sort of lab. All right, so subtract them. Same thing. What's the least number of sig figs? Well, because I'm subtracting, sig figs means decimal places. 2 decimal places, 3 decimal places, 2 decimal places. The least number is 2. You get this answer on your calculator, 93.12. Wait a second. The calculator got it right. Yay! Sometimes the calculator accidentally gets the math answer and the science answer the same. So there is much rejoicing in the land of chemistry. Just take the answer and go on. Yay! It's got it right. Because this is 2 decimal places. All right. Go ahead and do a level 3 question. Maybe make up a calculation, an adding, subtracting question, a multiplying or dividing question, and just ask for the answer. Any math problem that you make up, you can now think of the answer as a science answer. So do a level 3 type of question, make a prediction about something. Sorry, that example I just said about making up a new math calculation, that would have been a level 2 question. A level 3 question, and this is maybe something you're thinking, so this would be a good level 3 question. Argue or defend why we need to have sig figs in science. That would be a wonderful level 3 question so that you can think in your brain, why is this important? Why do scientists have to think about this? Okay. Whew. That was a lot to think about. You need to take a little break at this point. So no matter what else is going on, take a little break so you can kind of digest all this info. You need to process what you just learned. I do have a sig fig worksheet for you that has all of the different parts that we did. The first section is just looking at a number, how many sig figs. The second section is looking at a number and putting it in scientific notation with sig figs. And the third section is calculations. Give me the answer that is the science answer. For hours 1 and 3, this worksheet is due on Friday. For hour 4, the worksheet is due on Monday, just because I want you to have time to come to Zoom and ask questions before it is due. So come to your next Zoom with questions. I do want to remind you that all of these notes we just took today, these notes on sig figs are not on the Unit 1 quiz. So remember, we're going to keep using this all rest of the year, but it's so fast of a turnaround, you're not ready to be assessed on it yet. That brings us to the end of our day 5 of Unit 1. So go back and finish your Costa questions, do your summary, which remember was that zeros, synquane. Start the sig fig worksheet, even if you just do one problem from each section, just to get started on it. I know you have lots to do on Wednesdays. These notes were the most important thing, and maybe a little bit of review for the Unit 1 quiz, but maybe just start the worksheet and then it's due the next day after whenever your next Zoom is, depending on what hour you're in. You could also work on the changes lab report, which is due on Sunday. And then you could also do unit practice problems. Remember, on Wednesdays, my goal is that you're spending about an hour on chemistry. These notes took up a big chunk of that. So for the next half hour of that hour, you're doing the rest of these things. You are finishing your notes, start the sig fig worksheet, work on the lab report, do some review or something to finish off your time for today. But I am not expecting you to spend 3 hours of work on chemistry today, but you should spend at least 1 hour. That's kind of what we expect on Wednesdays. All right. Thank you so much for this exploration of sig figs and thinking about numbers like a scientist. This is a huge technical skill that is really stretching your brain, and that makes your brain stronger. Thanks for joining me. We'll see you at our next Zoom. Bye.